I think this is looking good, so let's go ahead and get started. Hi, Tor. Welcome. Welcome, everybody else, also to our Tech Talk number 37. My name is Helena, for everybody who doesn't know me. I'm the community manager for ALASCA. And as always, we are going to listen to Tor's Tech Talk. Then after that, there will be time for discussion. If you want to, you can also drop comments or questions in the chat during, and then we can talk about those after Tor's done with his presentation. Then I'm going to present some news and events, things that have happened within the foundation within the last month, and then I'm going to announce the next Tech Talk. So without further ado, please welcome everybody, Tor. From Cyberus Technology. He'll be introducing the Cyberus Hypervisor today. So I think I'm going to give you the mic. And
okay, there we go.
There you go.
Are you all right? Are you able to see that?
Yes. Yes, it's looking great.
All right. Well, very good. Yeah. Hi, everybody. I'm Tor. I'm from Cyberus, and today I'll talk a little bit about our hypervisor. You know, it's a pretty interesting component to talk about, and so I want to try to sort of cast some light on what it is we're doing here at Cyberus, and then we see where it goes from there. Well, one thing, questions anytime. Feel free just to raise your arm, and I think Helena will manage the questions. And if the questions are too difficult, I'm happy to say that I have Matthias Gries with me, who can then maybe step in if I get in trouble and it's above my pay grade to answer the technical questions. So thank you, Matthias, for backing me up there. Thank you also to the ALASCA community for inviting us to talk. And yeah, hopefully I can cast some light on what we're doing. First, very briefly about Cyberus. What is it? What are we? Well, we're a small company founded in 2017. We are about 35 people now. A few claims of fame. We are in fact the discoverer of Meltdown and Spectre back in the day. These are these side channel, and that created quite the buzz, and has of course sort of put our name a little bit in the list together with Intel and AMD, and that was a very positive thing for us as a small company. Perhaps not so much positive for the x86 architecture, as that was a pretty big scare. We do some other things. We've worked with Oracle on VirtualBox. We work with Seconet on their virtualization solution. We also work in this Apiro context with SAP. And of course, one claim to fame that I'll talk a lot about today is this Einsatzerlaubnis, or the VS-NfD accreditation process that we are working with. Yeah, we are here because we are open source enthusiasts. We are founding members both of ALASCA and of Neonephos. And pretty much everything we do is now open source. That has not always been like that. We work a closed source shop to begin with, first couple of years. So on the left-hand side, you see this product SVP, Secure Virtualization Platform. That is indeed a closed source microkernel-based virtualization solution, which still is deployed and we're supporting it, but principally everything we do today is open source. All right, the agenda for today, I'll talk a little bit about definition and context. This virtualization and hypervisor is often a little bit shrouded in mystery. It's a component that everybody uses. It's a technology that everybody has heard about, but what it actually is, and a little bit of the language, I'll spend some time on that just to make sure that what I talk about matches what you're hearing. That doesn't mean that it is the only definitions out there. There's lots of, let's call it lots of opinions in this space, but just so that we're on the one page, I want to just spend some time defining what we're talking about today. Also, a little bit about the Cyberus Hyper. What is it actually? You know, there's a million hypervisors out there. What is so special about the Cyberus Hypervisor? Then we'll talk about BSI and accreditation and why we are in this space at all. We'll talk about some industry use cases, performance benchmarking, what we're doing as next, and then of course questions, ask them anytime. And if I get in trouble, I have Matthias to help me. A little bit about definitions. What is a hypervisor? A hypervisor is a software blob that enables compute tenant separation. That is, in German, Mandantentrennung. That means it's the ability for more users, Mandanten, to work on the same exact hardware without the users individually noticing that they are sharing the hardware. All right, this is what all hypervisors do. Nothing special about that. Tenant separation, that is the feature that enables people to different users, organizations, tenants to compute their workloads simultaneous of shared hardware. In a little bit embellished, you could say that virtualization or hypervisor is the thing that allows cloud computing, allows shared infrastructure between tenants, between organization, between users. Virtual machine monitor is one of two components. It is an unprivileged software component, so it's a user application which utilizes the hypervisor to create virtual machines and all this stuff, including creating virtual hardware. And this is very important because the naming around cloud hypervisor and Cyberus hypervisor is actually a bit confusing. The name cloud hypervisor is not very ideal because the cloud hypervisor is not a hypervisor. It is a virtual machine monitor. The hypervisor is the KVM, so kernel-based VM, and that is a hypervisor which is directly integrated into the Linux kernel. Cloud hypervisor is a modern VMM. It's something that's been created in the last 3, 4, 5 years, and it utilizes the KVM hypervisor to create, manage VMs under Linux. A key point is that this VMM is written in Rust, so it is memory safe, thus avoiding the absolute vast majority of issues that CVEs that have come up in other hypervisor contexts. The Cyberus hypervisor, that is the Cyberus code, the expertise, methodologies, services around KVM, cloud hypervisor, and libvim. Okay, that is our features, our patches, monitoring, security updates, all that stuff that we do to make the cloud hypervisor KVM combination into a product. It's a key point that this is not a hard fork. It is all the stuff that takes the open source project cloud hypervisor and KVM and make it into a useful blob, useful thing that people can deploy as part of their stack, their solutions. Of course, the Cyberus hypervisor is BSI accredited or is on the way there, and that does make it different from the cloud hypervisor, not in code, but in the surrounding support stuff. And finally, virtualization stack, software component that it's the whole stack that needed to do this sharing of VMs, control, all that good stuff. So a little bit of Cyberus context. What is it that we do? What we do at Cyberus, we build these low-level open source tech modules. We will talk today mostly about secure tenant separation, multi-tenancy, but Cyberus is also interested in the part of block storage cryptography that sits in the hypervisor. We are by no means claiming that we're building a full-blown end-to-end block storage crypto, but every block storage cryptographic solution has a component that sits in the KVM Cloud Hypervisor, Cyberus Hypervisor context. The same thing goes for confidential computing. There's a attestation that is outside of the low-level plumbing, but we build the low-level plumbing that enables the stuff, all the surrounding stuff. We do not own the complete confidential computing implementation. We also work on low-level Linux distribution. We are not alone in that. Garden, SAP has their Garden Linux. We use that. There's also in the Secunet context this thing called 7OS. And there's other Linux distribution that we are interacting with and basing on. But that's the whole point. Today, I'll talk about the secure tenant separation, the hypervisor. So what's the deal here? The Cloud Hypervisor project, that is a young, that is a young project that is in the Linux Foundation, not Linux Foundation Europe, but Linux Foundation generally. And the founding charter for this project was signed in December 2021. So relatively young project. And this young project has a lot of hard edges. And one of those hard edges is that it does have broad industry support, but the development is sort of an on and off affair. It's not like Intel or AMD or anybody's really massively investing or have massively invested consistently. That's a little bit of a sort of a, yeah, it's a classic open source where there are some enthusiasts around contributing and there's some support. There's lots of people that are interested in this. You see the list on the right-hand side. And Cyberus Technology is one of those that are pretty active. We are indeed so active that Cyberus is now a maintainer for the Cloud Hypervisor code together with Meta and a company called Crusoe. And the three of us, together with the steering committee, we will have some impact in how the Cloud Hypervisor evolves. And it's a very, very positive and interesting collaboration with these other partners. Overall, that is what the Cloud Hypervisor project is. Now, what is the Cyberus Hypervisor? You can view it as the productification of the Cloud Hypervisor for our Cyberus egoistic purposes. Right? We have this open source project and we're taking that project and we're finishing it, or we're evolving it in all the places where we think, together with our customers, that it is needed. What does that mean? It means we're completing some of the missing feature set. We have in the last year added live migration to this. We've added Windows support. We have added this thing, CPU profiles, which allows you to live migrate between different generations of hardware. We're in the process of building a project around confidential compute, again, enabling the plumbing of the Cloud Hypervisor so that it becomes a useful product down the road. We're also testing this on a broad set of hardware. It's expensive fun right now with the prices that we have in memory, but this is very important on Intel, on AMD, on ARM. RISC, okay, that's maybe embellished a little bit. We're not that far yet, but from a vision perspective, also RISC is a plausible hardware candidate down the road. We're working on smooth cloud integration. That means there is this thing called libvirt. That's a libvirt operator that is essentially the bridge between the hypervisor space and the control plane space. And that goes both for legacy control plane, OpenStack. We are working there in the NeoNephos context on this thing called Cobalt Core, and a cloud native context where we're, again, in the NeoNephos context, working with Iron Core, so cloud native Kubernetes. Again, we're using the libvirt operator as the bridge between the cloud hypervisor KVM virtualization stuff and the control plane that's needed to do stuff with it. We've enabled a REST API for edge applications. Some of you may know the project secondly, that is the ALASCA open source project. That is a smaller, more efficient, streamlined, compact control plane layer that adds multi-tenancy to edge type of devices. I'll talk a little bit more about that. As part of the productification of the cloud hypervisor, we have done all this work around the BSI accreditation. This has been a phenomenally interesting travel for us. I will talk more about that also. But how do you make this thing accreditable? And that is a process that we're working with really talented and capable people, both at BSI itself, but also at a firm called ATSEC. And it's been really interesting project for us. And we're very happy about how far we have come. I'll speak more about it. We also provide integration services, CVE monitoring of Linux, of KVM, Cloud Hypervisor, and this libvirt component. That is, we communicate with our customers, we do the fixes that we can control, we manage, we make sure that our customers always have the latest and greatest fixes. Again, a key point. Cyberus Hypervisor is not a hard fork of the Cloud Hypervisor. It is, first of all the code that we are writing is upstreamed in the main trunk for Cloud Hypervisor. So far, we have a pretty good track record of getting everything upstream, but we're not completely there yet. But it's very important that you recall that Cyberus Hypervisor is not a fork of Cloud Hypervisor. It is all the stuff around that makes the Cloud Hypervisor into a blob that is productizable. Okay, let's talk a little bit about BSI and accreditation. So, why Cloud Hypervisor? Well, we have to start here with an observation. There are tons of really capable hypervisors out there. Every hyperscaler has one, and there are lots of open source. You have QEMU, you have VirtualBox, you have Zen, you have, Nitro, I think, is the one that Amazon is using. We have our own secure virtualization platform that I mentioned. There's simply, there's nothing fundamentally special about a hypervisor. So what is so special then? Well, the grand technical challenge that we're working on is, how do you construct a virtualization stack that is, first of all, inherently secure, that is actually secure, or actually so secure that you can make it, or as secure as you can make it. Many people are working on this, and in no way can I claim that our Cyberus Hypervisor or the cloud is fundamentally more secure than what Amazon or Google or anybody else is doing. Everybody is probably doing a really good job here. But the code also has to be accepted as legitimately secure, right? That means it cannot be based on a trust me methodology or take my word for it, right? Obviously, we are now going into this open source space. So it's got to be legitimately secure, inherently secure, and you also got to be able to show it. And then last, it's got to be digitally sovereign. Digital sovereign is a word that everybody's using, and I don't even know what it means. I can tell you, or I will come to that, what it means is co-developed and supported in Germany. That is what it means to us. And so in order to solve this overall technical challenge, a good starting point for this is a report that the BSI wrote in 2019, I believe, 1920, something like that. And what it does is that it compares the cloud hypervisor construct with this really amazing QEMU construct that has been existing for a very long time. And what they're saying is that, okay, look at the trusted compute base size. Well, whereas the cloud hypervisor is, well, 100K lines of code, QEMU comes in with their fabulous device and legacy support with everything at close to 6 million lines of code. Right there, you see the problem. Memory safety, well, cloud hypervisor is written in all Rust, 100%. QEMU is mostly C. And if you look at the history, the CVEs that come, they are mostly memory safety related. So there is a huge track record of CVEs that come to this, towards the memory safety. And that track record is zero on the QEMU, on cloud hypervisor side. That is, memory bugs are prevented by design. That doesn't mean there are not other CVEs in the cloud hypervisor space, but a vast majority of them are just eliminated by design. QEMU supports a fabulous amount of legacy devices. Cloud hypervisor does not. Cloud hypervisor is lean, mean, and focused on cloud operation. And it does not have any, or not a very much backwards compatibility. Smaller SBOM, modular design versus huge. So what you have is a general purpose on the right-hand side that works for pretty much everything. And then you have on the left-hand side, you have a very streamlined, very almost egocentric approach to just do the very minimum. And the conclusion that we've taken from this report is that it is, if somebody is crazy enough to come to BSI with a KVM cloud hypervisor based hypervisor, BSI accreditation might just be possible. If you come to them with a KVM QEMU approach, we're not saying that it is impossible, but it is a tough one. It is a really tough one, and it's certainly above our abilities as Cyberus to argue for the safety of QEMU. So that is why we decided, hey, we're going hardcore with a KVM cloud hypervisor based solution. And we have, in October last year, we received the so-called Einsatzerlaubnis. That is a temporary Erlaubnis, permission to deploy this in a public authorities type context in Germany. I had hoped to show you the actual official accreditation. We are not there yet. We're probably 2, 4, 6 weeks away from getting the official accreditation for our hypervisor for the 1.0 version. It has been a pretty steep learning curve for us, but again, it's been a very impressive learning curve in that we've been working with some really capable and talented people, both by BSI and by this company that's helping us, and so we think we're actually converging towards that's actually genuinely accreditable. So where do we use this thing? What's up? Well, it turns out that there is quite a lot of use cases where this is interesting. Some of them may not apply directly in this forum, but I'm talk about them anyway. One is as cloud edge use case. It turns out that multi-tenancy is starting to mean something at the cloud edge. And this is example of a medical, for the regulated market is from Seconet. It is deployed since, it's production deployed since October 2024, if I recall correctly. And what is important about this is our hypervisor is running, the 1.0 hypervisor has been running in this thing for that time. There are thousands of units physically deployed in the field. It is interesting. One of the father of one of the people work at Cyberus, he has what's an apothecary. He sells medicines. I don't recall what the English name is, but they have one of these boxes with our code running in it. It makes us, of course, feel really good. But what is really important is that this project that we've very proudly done together with Seconet has allowed us to test out our open source business model. And it turns out this is absolutely possible. And that is, in this community here, it is really, really important that we all speak with one voice, that open source is not free source. We have to also work with our customers and partner around how we make this work for the people who not just build the code, but also maintain it. There are tons of maintainers all over the world that do not get compensated for their brilliant work, and we use that brilliant work. So it's important that we insist relative to our customers, but also relative to ourselves, that we make sure that the open source community also has a commercial and constructive future. And this project, a very trusted long-term partnership, is an example of that, and I'm really happy to talk about it. Another example, this is a prototype. This is the company Veritas. We've talked about this in our blog. They are looking at a gateway again, a multi-tenancy gateway that does identity scanning. And you can imagine that as a box where software from different vendors run. One has a passport scanner with whatever technology is needed there. Another vendor has maybe biometrics and fingerprint scanning and access to some database that has to do with that. A third has to do with age checking, and a fourth. And you can put all this multi-tenancy in one box, saving that, the border guard or the whatever has to have 27 different computers for different vendors. That saves enormously the cost, as you can consolidate the compute onto one device that, with virtualization, with multi-tenancy, have different software from different vendors running in parallel, sharing the same hardware. As I said, this is a prototype, but again, it is a wonderful sort of collaboration, not just between us and Veritas, but you will see on the drawing that here runs 7 OS that Seconet has developed, and it is a collaboration between different open source teams to enable a really useful product at the top level. And the Veritas guys, they do not have to fundamentally worry about the hypervisor. We got that part. We got the hardware testing part. Seconet delivers the whole 7 OS operating system part, and there's also a test infrastructure associated with it. So there's a genuine sharing to build great products based on shared open source technology. Now, in the end, we are here in ALASCA, so we talk a lot about cloud. And one use case that is very important is transition to open source. Technologically, we have VMware out there and they're phenomenal what they deliver. Their technology is great, nothing negative to say about that. But in the last years or so, we've seen some complications around the business model and this whole concept of digital sovereignty. We can't be shut off by foreign governments that are increasingly hostile. And so open source, in our view, is an absolute legitimate use case. And I'm happy to report here that if you look at this stack on this side, public disk legacy cloud, so we're talking here OpenStack, we're talking here LibVit, we're talking here our virtualization stack. Well, SAP is deploying this right now. They production deployed this stack starting April this year, and they're rolling it out on thousands and thousands of computers worldwide. So what we are demonstrating here is the path from a closed source, trust me, you're secure. You are probably secure. I will not say that we in any way beat a VMware-based solution here technologically. That is false to claim. But we are an absolutely credible alternative as a complete open source stack. We have Garden Linux from SAP, part of Neonephos below us. We have our hypervisor in the middleware, and then Cobalt Core is open source. OpenStack is open source, and this product is working, it's running, and even SAP is talking about this very broadly. I have slanted out some logos left and right. The reason for that is that I have not had time to collect permission to show it, and I don't want to run into any kind of copyright infringements or anything like that. But I encourage you to take a look at take a screenshot of this and then look at the presentation from Michael Schmidt from SAP, where he shows this as part of the overall SAP context. The key message here, though, is that the Cyberus Hypervisor, with all the stuff that I talked about, is running production at SAP and is being deployed on a rather significant scale. Performance, that is we always get these questions about, how does the Cyberus Hypervisor or KVM Cloud Hypervisor compare to other solutions? And so then I'll show you some foils. I ask you to please apply a little bit of grain of salt. This is early days, and performance benchmarking is one of those things that you can easily bias your results one way or another. The screenshots that I'm showing you, we've tried to not bias them. We tried to give you as a fair assessment as possible, but please accept this with a little bit of grain of salt. We have nightly runs where we're comparing QEMU with Cloud Hypervisor. And we vary parameters such as virtual CPUs, memory, test duration, TCP connections, multi-queue, yes, no. I mean, there's a huge setup that we have. And the key, and this is running on various relevant platforms. This is, at this point, Granite Rapids and, Matthias, help me. Granite Rapids and...
I mean, we also have AMD platforms, and I believe we have 3 Intel platforms. So Granite Rapids would be Intel, and we have three different architectures. There are also older ones.
Right. So we're trying to make very good pictures of how this is performing. And I think from a network benchmarking perspective, we're feeling pretty good about it. I'm not going to make any claims that this is the end of the road and that, you know, QEMU has still lots of room to optimization, but at least as a snapshot, we're definitely in the ballpark relative to the established QEMU framework. The same thing goes, a little less perhaps, for I/O benchmarks. Again, we have multiple platform. We have all kinds of parameters, sequential, random, read, write, I/O depth, blah, blah, blah. And everything we see, we are probably okay. This is, of course, pretty important data for our customers. And so we're feeling pretty good, but this is early days. So I'm sure there will be interesting and positive evolutions going forward. The road ahead. What exactly are we doing as next thing? Well, first of all, if we look at the feature and accreditation roadmap, accreditation never ends, because for every new feature that is security relevant, and just that is a discussion in itself, the accreditation process starts anew. It is then an incremental process, but it starts anew. So what we are here, we are very close to getting this 1.0 accreditation, which is the basic plumbing that is running in the gateway that I showed you. Now, what it does not yet have is an accreditation for Windows VMs, live migration, CPU profiles. All of these features are what the hell? Sorry. All of these features are relevant, security relevant. So the moment we are done with accreditation 1.0, we will start a process of accreditation 1.1 and so forth. The next, in terms of features that we are building, confidential computing, block storage crypto. Again, this is very important. We in no way aim to deliver a comprehensive block storage crypto thingy. We aim to deliver the basic plumbing in the hypervisor that is needed to enable various block storage crypto solution, be that Ceph, be that something de-encrypt through OpenStack. We have to see this is a process of triangulating between the customer's needs, BSI, who has very, very strict requirements around cryptographic, and what we can do practically in the hypervisor. So this is not a project. This is a program that will have to go over years to evolve the underlying plumbing that we do to enable various block storage crypto solutions. That also go for confidential compute. I'll talk more about that in a moment. On the right-hand side, we talk about NATO restricted and EU restricted and geheim. There is a need for us to go there. We don't know enough about what it takes to go there to make a claim that we will go there. But we do have requests from the community around, hey, what's our story around geheim or secret? What's the story? And these are problems that we still have to figure out. Same thing, and that is useful to know. Nested virtualization, that is a feature that works in Cloud Hypervisor today. Going to BSI and saying, oh, we would like to certify, thus we guarantee that the nested virtualization implementation is secure, and if you use it in this way, that is a huge challenge. That is not something that we can just whoop out. So again, that is something that would require collaboration with a customer that absolutely need that component. So in other words, this is a roadmap we're talking about and not a one shot and we're done deal. I've talked a lot about evolving the underlying plumbing, the underlying modules, the low-level components. We do not, as Cyberus, we do not deliver, a finished block storage solution. We don't. We don't deliver a finished confidential computing thingy with attestation and this. There are other companies out there like Scontain, like Edgeless, like Enclave that are very, very good at this. And I know that there's a research project by Fraunhofer. There's all kinds of things going on in this confidential computing space. Our interest as Cyberus is to enable the plumbing in KVM Cloud Hypervisor. And now you may ask, KVM Cloud Hypervisor, why not just use QEMU for confidential compute? And that is a very, very good question. The reason why we think it's important for us to enable confidential compute for our accredited hypervisor is the CIA triad, right? Confidentiality, integrity, and availability. In-use protection requires all three, and QEMU is absolutely sufficient to guarantee confidentiality. It is also sufficient to guarantee the integrity, but the confidential compute threat model explicitly excludes denial of service, which means availability must also be guaranteed. And that is where we come in. And we are spending effort right now in order to ensure that confidential compute is available also to the accredited VS-NfD requiring community. This is a lot of work, but there is lots of dynamic both on the AMD side and on the Intel side to enable the underlying stuff, and we're in the middle of that. So now long term, now we're in vision space, maybe we're in a little bit of dream space. If you do a threat modeling, you'll find that KVM, the cloud hypervisor is lean. The cloud hypervisor is Rust. The cloud hypervisor is probably pretty good as a starting point for a secure system. KVM, it needs a little help. So we have a vision, what we call RVM, resilient virtual machine, is to basically remove, reduce, replace old modules in KVM with modern Rust. That is, rewrite these modules. That is obviously not something we can just do overnight. This is a big deal. It has to be worked out with the KVM open source community. But from a vision and from a dream perspective, we want to move the ecosystem towards more and more secure open source stack. Well, KVM is kind of the next place where we see that we can make a difference. So we have a secret objective here. Not a secret, a strategic objective to long-term be able to also make a difference in the whole KVM community space by switching out, building, enhancing various modules, and thereby raising the overall security level of an open source stack. Which brings me to my last foil. Cyberus Hypervisor, we consider that our contribution, Cyberus contribution to a digital sovereign Europe. We aim to resolve this grand challenge that I talked about, is how do you construct a hypervisor, these low-level components, such that they are inherently secure? And we do that by lean, using Rust, and best practices software engineering test, accepted as legitimately secure and precisely not based on this trust me or take my word for it, That is open source. Everything has to be open source, and it has to be open source and pushed upstream. And you have to allow for scrutiny by neutral, non-profit actors. That means ATSEC, and excuse me, BSI-in-accreditation. You have to open up your code. They have to go through it. They have to see the code. They have to see your argumentation. They have to see your documentation. And only if they say, this is looking pretty good, and then we can communicate that we have achieved something that is probably legitimately secure. And again, as a last point, and this is why we are such happy participants, both in the ALASCA community, and my thanks and sort of happy thoughts goes out to Marius and the Cloud and Heat team for initiating this whole thing a few years ago, and also on the Neonefos Linux Foundation Europe. I think these are incredibly important initiatives, and we are very, very happy to be part of it, because I think our digital sovereignty thing starts here at home by not only developing the code, but also supporting it here at home in Germany and Europe. Thank you very much.
All right, thank you very much. I hope your room didn't get too hot in that meantime.
I'm in Kiel, so here we have nice winds, so it's actually quite okay here.
All right, that sounds good. Okay, thank you so much for your tech talk, and I'm going to open the discussion on this. If anybody has any questions, feel free to ask those now.
Well, that was easy. So I'm gonna just assume that everything was clear. I hope it was. Oh, Daniel, I see he's typing something. Congrats on your win. If you want to reach out to us, we have Matthias is my technical right-hand man. Feel free to write him with questions, concerns, input, ideas for collaboration. We're very happy. Yeah, exactly. Okay, second lay. I talked a bit. So second lay was previously called SCI, separation control layer. It was a closed source initially project developed between a company called D3TN, Cyberus and Seconet in the context of Project 7. This SCL project was recently open source in the ALASCA community. Let me go back to it so I can just click on the link. Can you see that?
Yes.
Yeah. So this is it's a minimal infrastructure as a service layer. It is completely in Rust, written in Rust. Now, it is not yet full features to where it can replace something like Proxmox or something, but it goes in that direction of a very elegant solution for how to manage, for instance, devices such as the gateway platform. So they are currently the gateway platform that I showed you. Is currently, let me click to that real quick, use case, is currently single tenant, but they're adding multi-tenancy to this. by bringing in a more advanced control plane, and that control plane is secondly. I encourage you, the person to talk to about this is the Dr. Now I forget, Walter.
Felix Walter?
Felix Walter, natürlich.
Yes.
Felix Walter, D3TN. He is, yeah, thank you.
You're welcome. It is hot.
I don't know, Felix, are you here today?
It's not looking like it. No.
No. But the D3TN guys, they are working this, and they are the right people to reach out to talk to. Daniel, I don't know if that helped you anything. Sorry. Okay.
Great. Okay. Any other questions?
All right.
If nothing's coming up right now, I'm sure, as Tor said, you guys can always reach out if you have more questions. And then I'm going to grab the presentation rights again. And try and fly through the updates on the community very quickly, just because it is hot. News number one, first and foremost, is a very important one and a very great one. The Focus project, so the funded through the SRB and State of Saxony funded ALASCA Focus project, was recently prolonged until the end of March 2027, which is really great news. And that means that these 4 people that you can see here are now allowed to work for ALASCA a little bit longer, and we can now just keep working on those association things that we've been working on, and it's really great news, and we are very excited about it. Other than that, what has happened within the last month, the most recent fifth article that was published, or magazine that was published, has an article in it for about ALASCA, which was written by Maria Vaquero from Cloud Technologies and Daniel Gerber from ALASCA Focus. So that's really great news. It's an all-round overview on ALASCA, the things that we do, our projects, our mission, our goals. And it's really well written. So if you are interested, then you can check that one out. Other than that, our hackathon is coming up. It's next week, actually. I think a few of you will also be joining us there. It's fully booked out. So that's great news. We're super excited about that. And we'll be spending 2 days just working and further developing our some of our projects. We'll be diving further into the SCOM, the Sonic community build that we're trying to launch in parentheses. And we'll have also 2 people from the TSC just looking at some ALASCA governance and working on a draft for the AI guideline for ALASCA. The ALASCA Summit is always an important talking point. The call for contribution is still running, and we would highly appreciate it if you guys would turn in your contributions. I know it's been open a while, but we are kind of moving into the last stretches. I think we have about a month left, so please go ahead and contribute. Other than that, I just want to let everybody know or remind everybody on the hotel of the location, because the summit this time around will be held within a hotel, and there are rooms, and we have blocked them all. And just so you know, because it's now not that long anymore, I think it goes until August the 2nd. So if you would like to book a room, then you can email the hotel or you can call. You find this information not only here, it's on our website. I've sent it around a few times. If you need it again, feel free to email me. Right, but just a reminder that if you want to book a room in that hotel, then you should hurry. Alrighty. Other than that, we are through for today, and we can all look forward to our next Tech Talk on July 31st, which will be held by Friedrich Zahn and Daniel Gerber. So those are the two ALASCA-focused software engineers that are now getting to work for ALASCA further. And they'll be giving a presentation on going full Arctic Circle, running ALASCA on open cloud infrastructure and standards. So that definitely is something to look forward to. And if nobody has any questions, concerns, dreams, and hopes, then we can go ahead and get lunch.
Thank you. Bye-bye.
Bye.